Good morning, explorers. Welcome to Virtual MOSI. My name is Charlie. I'm one of the amateur astronomers here at the Museum of Science and Industry in Tampa, Florida. It is my great pleasure to be talking to you today. Throughout the month of September, we are going to be highlighting the contributions of some great scientists you may have never heard of. And today, the scientist I want to talk about is Annie Jump Cannon. But before we actually get to the meat of what we're going to be talking about, I want to make sure that you realize you have a chat function. So if you have a question you want to ask of us, please write it in. And for that matter, if you want to answer a question we ask of you, do the same thing. Speaking of questions, here's a great one right here we're going to be answering today, and you can answer ahead of me if you think you know it. What is the connection between rainbows and the way astronomers classify the stars? That could be a puzzler. Well, let's take a look at some things, shall we? Now, this is a picture I actually took a couple of weeks ago after a rainstorm. There was a beautiful rainbow that was arcing across my neighborhood. Now, you may know rainbows. I hope you've seen some before. What causes a rainbow? Somehow, the rain that's left over from these storms splits light, white light from the sun, into all of its different colors. And we always see the colors in the same order, from red down to violet. So, what on earth could a rainbow have to do with classifying stars? Well, I'm going to show you another picture of some pretty stars. So check these stars out. What do you notice about them? This is a beautiful picture, by the way, taken by the Hubble Space Telescope. What do you notice about these stars? Well, I'm hoping you notice how colorful they are. Stars are not all one color. They're not all just white dots in the night sky. Now, Hubble has an especially sensitive eye to pick up all kinds of colors, but you too can see star colors as well, and we'll give you a chance to do that towards the end of the video. So what on earth could this have to do with rainbows? How are these colors connected? Well, that's part of what we're going to explore. Before we get to the scientists I want to talk about, I'm going to talk about a scientist you have heard about, Sir Isaac Newton. Oh, he was famous for a lot of things. But one of the things that he studied was how white light can get broken by a prism into its different colors. You may have seen such a thing at your school. Maybe your teacher has taken a chance to break light into the colors of the rainbow. What Sir Isaac Newton figured out is that when you're looking at all these different colors of the rainbow, they represent different temperatures. When he split the light into different colors, he put a thermometer under each one of these colors and found out they were actually different temperatures. And that was the beginning of the science of spectroscopy. Spectroscopy is the study of light that has been broken down into its components, and it is key to understanding how the stars and the heavens are all put together. Down here you see a spectrum, and notice how there are what we call absorption lines associated with different elements. We have hydrogen, sodium, and calcium. This is a spectrum from a star, and it shows what elements are in the star's surface layers. So we can actually tell what a star is made of by breaking its light down into its constituent colors. So how does that work a little bit? Well, let me show you something over here. This is called a spectral tube projector. What I've got here is a tube filled with hydrogen gas, the most abundant substance in the entire universe and the main thing that all stars are made of. I'm going to turn it on. Notice that beautiful color. What would you say that is? Maybe kind of a pink? It is a lovely color. Unfortunately, I can't leave it on a long time because the machine tends to overheat. But let's talk about that color. If I had a spectroscopy device, I could divide that pink color into about 6 or 7 other lines. Now, those lines would show exactly how the hydrogen atom is put together. So really how things are put together is what you're seeing when you see the way the light behaves. So that is hydrogen, as I said, the most common thing. But I want to actually still show you how those colors of the rainbow are really connected to the colors of the stars. And to do that, I got to talk about my hero today. My hero is Annie Jump Cannon. She was an American astronomer, born in 1863 that is, died in 1941. Now, first of all, you need to understand, when Annie Jump Cannon was an astronomer at Harvard University, all she was considered was a computer, a woman who took the plates of pictures that were made by men and she analyzed them. Women of that day weren't allowed to even touch the telescope, much less look through it. Okay, it was a man's world. They were just there to do all the work after the men had done making pictures of the heavens. Well, in about 1896, Annie joined Harvard University as one of Pickering's women, or Pickering's computers. Edward Pickering was the astronomer there, who of course got all the credit for everything the women did. Now, it's important also to understand that she overcame a whole lot other than just the fact that she was a woman. She was deaf from childhood, totally deaf. But that was not a hindrance to her. In fact, I think she used that to her advantage to enable her to focus on the work that she did. So what work was she given? Well, Edward Pickering at Harvard had something called the Draper Award. And what this was it was a study that was funded by a man named Henry Draper. And the idea was to classify as many stars as they possibly could by their spectra, by how the light from the star gets broken into all those colors I showed you a little while ago. Now, many people had tried to come up with a system for classifying stars, and all of them failed for one reason or another. Some were too complicated, some didn't really have any practical way to work. Well, let me show you what she came up with. This is her system for classifying stars. What we have here are 7 different classifications. Class O, B, A, F, G, K, and M. Now, we have added some classifications to the far end of the spectrum as we've found brown dwarf stars that they didn't even know existed until about 20 years ago. So we've had to add to it because we've made new discoveries, but this is still a system that is in use today. So if you ever want to remember, by the way, O, B, A, F, G, K, M, they have a mnemonic device. Oh, be a fine girl and kiss me, or be a fine guy and kiss me, whichever way you want to go. But that is the way astronomers for, well, almost a century now have actually memorized the order of the different star classifications. And basically what we do is we see different colors. Down here are red stars, and as we go through the spectrum, up here are what we classify as blue stars. Now, it doesn't look totally blue, does it? But it is blue, certainly, as we see it. Now, when you're going from red to blue, your temperature of your star is increasing all the while. You see, a star's color is exactly a description of the temperature of the stars, and stars are many different temperatures. So the M stars are the cooler red stars, usually red dwarfs, but sometimes they are huge stars that are at the end of their life. Our sun, by the way, is a Class G star, specifically a Class G2 star. It is a yellow star. Even though the light looks pretty white to us, it is still yellow as far as the spectrum is concerned. Now, one thing that really amazes me when I think about it is Ms. Cannon came up with this system, and it is still used today. She also used this system to personally classify nearly 400,000 stars by herself without any computer assistance by eye. And the thing that's amazing is that Draper catalog of star classifications is still used today, and practically none of the star classifications she did has ever been changed. So let's see what this looks like when we try and map out how the stars are distributed. Later astronomers, Hertzberg and Russell, came up with a diagram to try and show where all the stars in the universe fall. Most stars are along this line here, which are called main sequence stars. That's our sun right there, a yellow star. So here are the red, small, cool dwarf stars, but as I said, some red stars are huge giants. Then we have at the other end the blue stars, the hottest stars. And again, notice up here, that's Annie's work right there, still used today to classify stars. Now, you may be saying, well, okay, that's great, but don't you have to have a spectrograph and stuff like that, expensive equipment to classify stars? Actually, no. Your own two eyes can do a pretty good job of it. A very famous constellation of the winter sky is Orion. Maybe you're familiar with it. Always easy to find because of these three stars lined up along his belt. We call those the belt stars because we're really creative. But when you see the constellation of Orion, you are seeing some interesting different stars. Now, I want you to take a moment to look kind of carefully, especially at this star, which is Betelgeuse, but you probably know it as Betelgeuse, and this star down here, which is Rigel. Okay? You can definitely notice a difference in the color of these two stars. This one is a definite red. That one is a blue. Now let me tell you about these stars because I'm going to give you some homework. Now currently, okay, right now it's September 3rd, okay, I was out there just this morning looking at the sky at about 6 o'clock this morning. To find Orion, if you look to the east, the first thing you'll see is bright white planet Venus. You can't miss it if it's clear at all in the morning. Okay? To the right and up from planet Venus, you will see this constellation of Orion. He's tilted on his side. Okay, so his belt stars are going to be going like that instead of the way you see him here. When you find Orion, try and look carefully at the stars that you see. You will see it is very easy to tell that Betelgeuse is a red star. It really shows up easily. Even in our Tampa skies, it shows up well. Betelgeuse is a much cooler star than our sun. Our sun, as a yellow star, is about 10,000 degrees Fahrenheit at its surface. Betelgeuse is no more than 7,000 degrees Fahrenheit at its surface. It's a much cooler star, and that's why it shows red. Betelgeuse, by the way, is also a humongous star. If I put this star in our solar system, it would swallow up all the planets through Jupiter, would be inside the star. That's a big star, folks. Now, look at the other end. This star is called Rigel. Rigel is a blue giant star. Now, I told you that our sun was a toasty 10,000 degrees Fahrenheit. But when you look at a star like Rigel, you're looking at a star there that is 22,000 degrees Fahrenheit, more than twice as hot as our sun. That's crazy hot. This star is also like 800 light years away, so it really shines through because it is an immensely powerful, hot star. So this would be a class O star, okay, one of the hottest stars. This would be a class M star, and our sun's in the middle. Now, if you have a hard time picking up the blue color when you're looking at Rigel tomorrow morning, look down here, follow Orion's belt down below the picture where I don't have it, and you'll see a bright white star named Sirius, which happens to be the brightest star in the entire night sky. Sirius shines at a searing 17,000 degrees Fahrenheit. Okay, it is a class. Oh, be a fine guy and kiss me. Okay, it is a class F star. Now, if you look at Sirius down here, the white star, or for that matter, you look over here at Venus, a very white planet, you'll be able to see better that this is really a blue color, not exactly white. Okay, you have to kind of use a little imagination, but you can definitely see it. So when you're seeing these different star colors at night, that's what you're seeing is the temperature. We can't do the work that Annie does just by looking at the star by eye, but you can certainly see that what she did is right on. Now, this is something I always want you to remember. Always be discovering, okay? Never let anything get in your way. She didn't let the fact that she was deaf get in the way. She didn't let the fact that she was a woman get in the way. Towards the end of her career, Annie Jump Cannon finally received all the accolades that she was due. She became the first woman to ever receive an honorary degree from Oxford in England, the first woman ever to hold an officer position in the American Astronomical Society. And after many years at Harvard, only a couple of years before she retired, she became an endowed professor of astronomy at Harvard. Okay? It was a big, long journey, but as long as you keep discovering, keep paying attention, keep using your mind, there's no telling where you're going to go to. Maybe you'll end up in the stars. I hope so. Join us next time on Virtual MOSI for something else and another one of the heroes of science.